Alright, today we are looking at reviewing how to write lines in both slope-intercept form and point-slope form. So let's go ahead and start with writing the equation in point-slope form. Don't forget your general form of what point-slope form looks like. We are replacing our slope and a given point at x1, y1. So when I look at my information I was given, here's my point, that's my x1, my y1, and there's my slope. All I'm going to do is plug it in. So I've got y minus my y1. My y1 is a -1, so I'm subtracting a negative, which makes it a +1, equals m, which is my slope, and I'm given my slope is 4. And then x minus x1, and my x1 is 3. So remember, all I'm doing is substituting in my slope, and then my point at x1, y1. When I write an equation in slope-intercept form, I need two things. I need a slope and I need a y-intercept. The most important thing to remember is that y-intercepts are listed at 0, b. So in order for it to be a y-intercept, that x-coordinate must be 0. When I look at the point that I'm given, my x is not 0, therefore I'm not given my y-intercept. In that case, I have to start in point-slope form. So y minus my y1 equals my slope times x minus x1. Minus a -2 gives me that +2. Now this, remember, is just point-slope form. I want to get into slope-intercept form. And slope-intercept form is that y equals mx plus b, which means basically I just want to solve for y. So if I want to solve for y, the first step is distributing that 1/2. So I get 1/2 x. 1/2 times 2 is just 1. And then I have minus 0. I could add over 0, but adding 0, subtracting 0 is not going to change anything. But if there was a number there, remember that you would have to move that over to get y equals 1/2 x plus 1. And that's my equation in slope-intercept form. Now sometimes I'm not given a point and a slope. In this case, I'm given 2 points. Remember, anytime that you have 2 points, think about what you still need. If I'm looking for slope-intercept form, I'm still looking for that slope. Given 2 points, I can use our slope formula. y2 minus y1 minus a negative means I'm adding, over x2 minus x1. I'm subtracting a negative, so I'm adding. That gives me a -3/9, which is a -1/3. Now I have my slope. You get to choose which point you want to use. Most of the time, most people just choose our first one, but it doesn't matter. There's your x1, your y1. We aren't given our y-intercept. Neither one is x-coordinate is 0. So again, I have to start in my point-slope form. Y minus y1 minus a negative becomes a positive, equals your slope, which is a -1/3. X minus -6 is x plus 6. Then we distribute. Y plus 2 is equal to a -1/3 x. A -1/3 times 6 is a -2. The last step is we want to get y by itself, so we subtract that 2. And we get y equals a -1/3 x minus 4. Don't forget that you would have gotten the exact same answer if you would have used 3, -5. So it does not matter which point you choose in the beginning. Alright, let's make this a little bit harder. We get into problems when we don't necessarily have that clear of a direction, or we have a lot of things going on. So we want to write the equation of a line in point-slope form that is perpendicular to the given line and going through the given point. The most important thing is deciphering what you need, what's important. So as soon as I read this, I'm going to underline point-slope form. That's important to me. I'm going to first identify the fact of what form I need to write it in. Then I'm looking for perpendicular. Remember, perpendicular is referring to slope. I need opposite and reciprocal slope to this line going through that point. So the first thing I need to do is I need to find that slope. 3 is not your slope. Remember, it has to be in slope-intercept form. So I've got to solve for y. I move that 3x over. So we've got 2y equals a negative 3x plus 12. We divide by 2. And we've got y is equal to a negative 3 halves x plus 6. So from my given line, I have a slope of a negative 3 halves. I want perpendicular. My perpendicular slope opposite of negative is positive. Reciprocal is 2/3. And then last, don't forget, I want it to go through that point. So I'm using my perpendicular slope, my point negative 1, 5, and most important, I want it to be in point slope form. So think about what form it has to be in. Point slope form, I'm looking for my answer to be in this form. All I'm doing is substituting in that slope and my point. So we get y minus our y coordinate of 5, our slope of 2/3, x minus our x1 minus the negative means we have a positive 1. You stop there for point slope form. Last one, write the equation, slope-intercept form, parallel to our given equation through our point 27. Remember, parallel means we want the same slope. When we look at our line, we are given slope of 4. If I'm looking for parallel, it's exactly the same. So for my new equation, I'm using that parallel slope of 4. It's going through that point 27, and I want it to be in slope-intercept form. For slope-intercept form, I look, am I given the y-intercept? No. So I have to start, not finish, but start in point slope form. Y minus your y1 of 7 equals your slope of 4, x minus x1 of 2, distribute, and we get 4x minus 8. We add our 7 over, and we get y equals 4x minus 1. Don't forget, you have to pay attention to what form it's talking about. Slope-intercept, point slope. That's going to tell you where you need to stop. And that is your review for now.